Okay, Assalamualaikum and very good morning. Module 10, LAN security. So this module actually will explain how vulnerabilities compromise LAN security. Under this topic, we have a couple of subtopics. First, endpoint security. So this module or submodule will explain how to use endpoint security to mitigate attacks. And then second submodule regarding access control. So this will explain how AAA or AAA and 802.1 Act are used to authenticate LAN endpoint and also devices. Another subtopic, layer 2 security threats. This module will identify layer 2 vulnerabilities. And another subtopic, which is MAC address table attack. So it will explain how a MAC address table attack compromise LAN security. And for the final one regarding LAN attacks, so this submodule will explain how LAN attacks compromise LAN security. Okay, all right. So 10.1 endpoint security. So network attacks today. So the news media commonly covers attacks on enterprise network. Simply search the internet for latest network attack to up-to-date information on current attack. Most likely, this attack will involve one of the following issue. First, DDoS or distributed denial service. Normally, we call DDoS. So this attacks actually is a coordinated attack from many devices called zombies with the intention of degrading or halting public access to an organization website and resources. Okay. And next, regarding data breach. So this attack, this is an attack which an organization data servers or hosts are compromised to steal confidential informations. Okay, another attack called malware. So this attack in which an organization hosts are affected with the malicious software that cause a variety of problems. For example, ransomware such as WannaCry encrypts the data on host and locks access to it until a ransom is paid. Okay. So this is the kind of attack recently. Okay. Recently, according to this slide written, so up to the when this document has been created for you. Okay. So this is current and also the latest one. Yeah, this one. So network security device. Various network security devices are required to protect the network perimeter from outside access. These devices could include the following, like VPN enable router. Yeah, so it provides a secure connection to remote users across a public network and into the enterprise network. VPN services can be integrated into the firewall. And then for the next device is NGFW, means next generation firewall. So it provides sticks full packet inspection, application visibility, and control. So next generation intrusion prevention system, NGIPS, advanced malware protection, AMP, and also URL filtering. So NAC device is network access control, or NAC. So it includes authentication, AAA authentication, authorization, and also accounting services. So in large enterprises, these services might be incorporated into an appliance that can manage access policies across a wide variety of users and device types. The the Cisco Identity Services Engine (ISE) is an example of an AC device. So endpoint protection. Endpoint are hosts which commonly consist of laptop, desktop servers, and also IP phones, as well as employee-owned devices. Endpoint are particularly susceptible to malware-related attacks that originate through email or web browsing. Endpoint have typically use traditional host-based security features such as antivirus, anti-malware, host-based firewall, and also host-based intrusion prevention system. Then for the endpoint today, are best protected by a combination of NAC, AMP software, and email security appliances, ESA, and WSA, which is web security appliance. So this is the example right now, yeah. So Cisco email security appliance. The Cisco ESA device is designed to monitor SMTP, or Simple Transfer Protocol. The Cisco ESA is constantly updated by real-time feeds from the Cisco Talos, which detects and correlates threats and solutions by using a worldwide database monitoring system. This threat intelligence data is pulled by the Cisco ESA every 3 to 5 minutes. These are some of the function of the Cisco ESA. So first, a block known threats. Second, function remediate against steal malware that evaded initial detection. Another function, discard email with bad links. Another function, blocks access to newly affected sites. And another final function is encrypt content in outgoing email to prevent data loss. So Cisco Web Security Appliance, Cisco Web Security Appliance, or WSA, is mitigation technology for web-based threats. It helps organizations address the challenges of securing and controlling web traffic. The Cisco WSA combines advanced malware protection, application visibility and control, acceptable use policy control, and reporting. Cisco WSA provides complete control over how users access the internet. Certain features and applications such as chat, messaging, video, and audio can be allowed, restricted with time and bandwidth limits, or blocked according to the organization requirement. The WSA also can perform blacklisting of URL, URL filtering, malware scanning, web application filtering, and encryption and decryption of web traffic. Next, 10.2 access control. So authentication with a local password. Many types of authentication can be performed on network devices, and each method offer varying levels of security. The simplest method of remote access authentication is to configure a login and password combination on console, VTY lines, and aux port. SSH is the most secure form of a remote access because it requires username and also password. The username and password can be authenticated locally. So local-based method has some limitation. User account must be configured locally on each device, which is not scalable. So the method provides no fallbacks, yeah, authentication method. AAA component. AAA stands for authentication, authorization, authorization, and accounting. So they provides, the primary framework to set up access control on a network device. AAA is a way to control who is permitted to access network which is to authenticate the user when they can do while they are there authorized, and to audit what action they perform while accessing the network, which is counting. Okay, that's means triple A. Yeah. So authenticate or authentication. Local and server based are two common methods of implementing AAA authentication. Local AAA authentication. This method store user and password locally in a network device. For example, in the Cisco router. So users authenticate against the local database. Local AAA or local AAA is deal for small networks. Server-based triple A authentication. With the server-based method, the router accesses a central AA server, triple A server. So the triple A server contains the username and password for all users. The router use either the remote authentication dial-up user service or Radius, okay, or terminal access control system, TACACS, okay, TACACS plus protocols to communicate with AAA server. When there are multiple router and switches, server-based AAA is more appropriate. Authorization. AAA authorization is automatic and does not require users to perform additional step after authentication. Authorization governs what users can or cannot do on the network after they are authenticated. Authorization use a set of attributes that describe the user access to the network. These attributes are used by the IEEE server to determine privileges and also restriction for that user. Triple accounting collects and report usage data. This data can be used for such purposes as auditing or billing. The collected data might include the start and stop connection times, executed commands, number of packet, and also number of byte. A primary use of accounting is to combine it with AAA authentication. The AAA server keeps a detailed log of exactly what the authenticated user does on the device, as shown in the figure. Okay, this includes all exec and configuration command issued by the user. The log contains numerous data fields, including the username, the date and time, the actual command that was entered by the user. So this information is useful when troubleshooting devices. It also provides evidence for when individuals perform malicious acts. 802.1x. The AAA 802.1x standard is a port-based access control and authentication protocol. This protocol restrict unauthorized workstation from connecting to a LAN through publicly accessible switch port. The authentication server authenticates each workstation that is connected to a switch port before making available any services offered by the switch or the LAN. With 802.1x port-based authentication, these devices in the network have specific roles, which for client is supplicant. This is device running 802.1x compliant client software, which is available for wired, including wireless devices. Switch authenticator. The switch acts as an intermediary between the client and the authentication server. It requests identifying information from the client, verify that information with the authentication server, and relay as response to the client another device that could act as authenticator is a wireless access point. Authentication server. The server validates the identity of the client and notify the switch or wireless access point that the client is or is not authorized to access the LAN and also switch services. So this is the diagram regarding the roles, yeah, the roles of the uh, every part, yeah, roles of the device, yeah. Okay. 10.3 layer 2 security threats. So layer 2 vulnerabilities. Recall that the IO reference model is divided into 7 layers, which works, yeah. Okay. Again, recall that the OSI reference model is divided into 7 layers, which work independently of each other. So the figure where this. So the figure shows the function of each layer and the core element that can be exploited. So network administrator routine implement a security solution to protect, yeah, to protect the implements in layer 3 up to layer 7. They use VPN firewalls, IPS devices to protect this element. However, if layer 2 is compromised, then all the layer above it are also affected. For example, if a threat actor with access to the internal network captured layer 2, then all the security implemented on the layer above will be useless. The threat actor could cause a lot of damage on the layer 2 LAN networking infrastructure. Switch attack categories. Security is only as strong as the weakest link in the system. And layer 2 is considered to be that weak link. This is because LAN were traditionally under administrative control of a single organization. We inherently trusted all persons and devices connected to our LAN. Today, with BYOD and more sophisticated attack, our LAN have become more vulnerable to penetration. Category of attacks we have MAC table attack. So it includes MAC address flooding attacks. For VLAN attacks include VLAN hopping and VLAN double tagging attacks. It also includes attack between devices on a common VLAN. And then for the DHCP attacks include DHCP starvation and DHCP spoofing attack. For ARP attack include ARP spoofing and ARP poisoning attacks. And for the address spoofing attack, it include MAC address and IP address spoofing attacks. STP attacks, this attack actually includes, so STP attack is include the spanning tree protocol manipulation attacks. So switch attack mitigation technique solution. So port security actually to prevent many types of attack, including MAC address flooding attacks and DHCP starvation attacks. And then for the DHCP snooping, it prevent DHCP starvation and DHCP spoofing attack. For dynamic ARP inspection or DAI, prevent ARP spoofing and ARP poisoning attacks. IP source guard, IP source guard or IPSG, prevent MAC address, MAC and also IP address spoofing attacks. This layer 2 solution will not be effective if the management protocol are not secure. The following strategies are recommended. Always use secure variants or management protocols such as SSH, Secure Copy Protocol SCP, Secure FTP as FTP, Secure Socket Layer, Transport Layer Security SSL, or TLS. Consider using out-of-band management network to manage devices and use a dedicated management VLAN where nothing but management traffic resides. Use ACL to filter unwanted access. 10.4 MAC address table attacks. Switch operation review. Recall that to make forwarding decision, a layer 2 switch builds a table based on the resource MAC addresses in receive frame. This is called a MAC address table. MAC address tables are stored in memory and are used to more efficiently switch frame. Okay, this is the command to see the MAC address table. Okay, MAC address table flooding. All MAC tables have a fixed size and consequently, a switch can run out of resources in which to store MAC addresses. MAC address flooding attacks takes advantage of this limitation by bombarding the switch with fixed source MAC addresses until the switch MAC address table is full. When this occurs, the switch treats the frame as an unknown, unicast, and begin to flood all incoming traffic out all ports on the same VLAN without referencing the MAC table. This condition now allow a threat actor to capture all of the frame sent from one host to another on the local LAN or local VLAN. Notes that traffic is flooded only with a local LAN or VLAN. The threat actor can only capture traffic within the local LAN or VLAN to switch the threat actor is connected. Okay, this is the scenario. MAC address table attack mitigation. What makes tools such as MAC-off so dangerous is that an attack can create a MAC table overflow attack very quickly. For instance, a Catalyst 6500 switch model can store 132, yeah, 1000 MAC addresses in each MAC address table. A tool such as MAC off, yeah, can flood a switch with up to 8000 bogus frames per second, and also it creating a MAC address table overflow attack in a matter of a few seconds. Another reason why these attack tools are dangerous is because they not only affect the local switch, they also affect another connected layer to switches. When the MAC address table of switch is full, it starts flooding out all ports, including those connected to other layer 2 switches. To mitigate MAC address table overflow attack, a network administrator must implement port security so that port security will only allow a specified number of source MAC addresses to be learned on the port. Port security is further discussed in another 10.5 LAN attack. Yeah, LAN attacks. Okay, this video you can get from the website regarding the VLAN and DHCP attacks. So it will cover VLAN hopping attack, VLAN double tagging attack, starvation attack, and also spoofing. Okay, VLAN hopping attack. A VLAN hopping attack enable traffic from one VLAN to be seen by another VLAN without the aid of a router. In a basic VLAN hopping attack, the threat actor configures a host to act like a switch to take advantage of the automatic trunking port feature enabled by default on most switch port. Yeah. So the threat actor configure the host to spoof 801.1q signaling and Cisco proprietary dynamic trunking protocol (DTP) signaling to trunk with the connecting switch. If successful, the switch establish a trunk link with the host as shown in the figure. Okay, this one. So now the threat actor can access all the VLAN on the switch. The threat actor can send and receive traffic on any VLAN, effectively hopping between VLAN. All right. So VLAN double tagging attacks. Another threat. So a threat actor is a specific situation could embed on hidden 802.1q tag inside the frame that already has an 802.1q tag. This tag allows the frame to go to a VLAN that the original 802.1q tag did not specify. Step 1. So the threat actor sends a double tag 802.1q frame to the switch. And then the outer header has the VLAN tag of the threat actor, which is the same as the native VLAN of trunk port. Next step, the frame arrives on a first switch, which looks at the first byte of 802.1q tag. The switch sees that the frame is destined for the native VLAN. The switch forwards the packet out all native VLAN ports after stripping the VLAN tag. The frame is not re-tagged because it is part of the native VLAN. At this point, the inner VLAN tag is still intact and has not been inspected for the first switch. Okay, next. Step 3. The frame arrived at the second switch, which has no knowledge that it was supposed to be in a native VLAN. Native VLAN traffic is not tagged by the sending switch as specified in 802.1q specification. So that the second switch looks only at the inner 802.1q tag that the threat actor inserted and sees that the frame is destined the target VLAN. The second switch sends the frame on the target or floods it, depending on whether there is an existing MAC address table entry for the target. A VLAN double tagging attack is unidirectional and works only when the attacker is connected to a port residing in the same VLAN as the native. The idea is that double tagging allows the attacker to send data to hosts or servers on a VLAN that otherwise will be blocked by some type of access control configuration. Presumably, the return traffic will also be permitted, thus giving the attacker the ability to communicate with devices on the normal block VLAN. VLAN attack mitigation. VLAN hopping and VLAN double tagging attacks can be prevented by implementing the following trunk security guidelines as discussed in the previous module. First, disable trunking on all access ports. Next, disable auto trunking on trunk links so that trunks must be manually enabled. Be sure that the native VLAN is only used for trunk links. DHCP messages. DHCP servers dynamically provide IP configuration information, including IP address, subnet mask, default gateway, DNS servers, and more to client. A review of the sequence of the DHCP message exchange between client and server is shown in the figure. All right. DHCP attacks. Two types of DHCP attacks are DHCP starvation and DHCP spoofing. Both attacks are mitigated by implementing DHCP spoofing. DHCP starvation attack. The goal of this attack is to create a DOS for connecting clients. DHCP starvation attacks require an attack tool such as Gobbler. Yeah, Gobbler has the ability to look at the entire scope of listable IP addresses and tries to list them all. Specifically, it creates DHCP discovery messages with bogus MAC addresses. DHCP spoofing attacks. These occur when a raw DHCP server is connected to the network and provide false IP configuration parameter to legitimate client. A raw server can provide a variety of misleading information, including the following issue, such as wrong default gateway, wrong DNS server, and also wrong IP address. Okay, so next regarding video or ARP attacks, STP attack, and CDP reconnaissance. Okay, this video will cover the following: ARP spoofing, ARP poisoning, STP attack, including SDP reconnaissance. So this video you can get from the NetAcad website, yeah, under this module, yeah. So ARP attacks. Host broadcast, yeah, ARP request to determine the MAC address of host with and destination IP address. All hosts on the subnet receive and process the ARP request. The host with the matching IP address in the ARP request send an ARP reply. A client can send an unsolicited ARP reply called gratuitous ARP. Other hosts on the subnet store in the MAC address and IP address contained in the gratuitous ARP in their ARP table. An attacker can send a gratuitous ARP message containing a spoof MAC address to a switch, and the switch will update its MAC table accordingly. In a typical attack, a threat actor sends unsolicited ARP replies to other hosts on the subnet with the MAC address of the threat actor and also IP address of the default gateway, effectively setting up a man-in-the-middle attacks. There are many tools available on the internet to create ARP man-in-the-middle attacks. IPv6 use IPv6, sorry, IPv6, yeah. It use ICMP v6 Never Discovery Protocol for Layer 2 address resolution. IPv6 includes strategies to mitigate never advertisement spoofing, similar to the way IPv6 prevents spoof ARP reply. ARP spoofing and RIP poisoning are mitigated by implementing dynamic ARP inspection or DAI. Yeah. So address spoofing attacks. If address spoofing is when a threat actor hijacks a valid IP address of another device on the subnet or use a random IP address. IP address spoofing is difficult to mitigate, especially when it is used inside a subnet in which the IP belongs. MAC address spoofing attacks, yeah. MAC address spoofing attacks occur when the threat actor alter the MAC address of their host to match another known MAC address of a target host. The switch overrides the current MAC table entry and assign MAC address to the new port. It then inadvertently forward frames destined for the target host to a attacking host. When the target host sends traffic, the switch will correct the error, realigning the MAC address to the original port. To stop the switch from returning the port assignment to its correct state, the threat actor can create a program or script that will constantly send frames to the switch so that the switch maintains the incorrect or spoof information. There is no security mechanism at layer 2 that allows a switch to verify the source of MAC addresses, which is what makes it so vulnerable to spoofing. IP and MAC address spoofing can be mitigated by implementing IP source guard or IPSG. STP attack. Network attackers can manipulate the STP or the S-spinning tree protocol to conduct an attack by spoofing the root bridge and changing the topology of a network. Attackers can then capture all traffic for the immediate switch domain. To conduct STP manipulation attack, the attacking host broadcast STP bridge protocol data unit or BPDUs containing configuration and topology changes that will force spanning tree recalculation. The BPDU sent by the attacking host announce a lower bridge priority in an attempt to be elected as a root bridge. This STP attack is mitigated by implementing BPDU guard on all access port. BPU guard is discussed in more detail later in this course. CDP recognition. A CDP is a Cisco Discovery Protocol. It's a proprietary layer 2 link discovery protocol. It is enabled on all Cisco devices by default. Network administrator also use CDP to help configure and troubleshoot network devices. CDP information is sent out CDP enabled port in periodic encrypted and authenticated broadcast. CDP information includes the IP address of the device, IO software version, platform capabilities, and the native VLAN. The device receiving the CDP message updates its CDP database.